Moving on to the next example, so if we got negative 2 times vector x plus 5 times vector y is equal to vector A, and x minus 3 vector y is equal to vector B, find expressions for vectors x and y in terms of vectors A and B. Now this question comes up in your book a lot, and a lot of my students ask me for help with this kind of question fairly often. And there's a lot of algebra in this type of question, but if you follow the steps that I'm going to write out for you, it's fairly simple. So to begin with, let's write out these expressions here. So this would be negative 2x plus 5y equals vector A, and vector x minus 3y is equal to vector B. Now I'm going to number these expressions as 1 and 2 because I'm going to write out a bunch of steps and I'm going to be referring to these expressions here by their numbers. So the first step is we have to isolate for vector x in expression 2. We can also isolate for y or x or y in expressions 1 or 2. We could isolate for any variable. However, it's easiest to isolate for x because there is no number in front, so we won't end up with any fractions to work with. So let's rewrite expression 2. So x minus 3y equals b. So that means x is just equal to, if we bring the negative 3y over, it becomes positive 3y, so b plus 3y. Now for step 2, we're going to take the x vector that we found from step 1 and we're going to sub it in to expression 1 and then isolate for y. So let's start off with rewriting the first expression, so negative 2x plus 5y equals vector A. And now we're going to sub in this x here, so negative 2 times vector B plus 3y plus 5y is equal to vector A. And now we have to isolate for y, so let's distribute this in. So this would be negative 2b minus 6y plus 5y is equal to vector A. Now let's bring this negative 2b over, and then negative 6 plus 5, that ends up being negative 1y. And on this side we end up with A plus 2b because we brought it over. And then isolating for y, we would just divide everything by negative 1. So vector y is equal to negative A minus 2b. This is an equal sign here. So we answered part of the question. We got vector y in terms of A and B. Now our third and final step I'm going to do here because I was running out of room over there. So I'm going to take the y that we found in step 2 and I'm going to sub that into expression 2 and then isolate for x. So let's rewrite expression 2. Actually, you know what? Let's just sub in for y right away. So I'm just rewriting expression 2, but for this y, I'm going to sub in negative a minus 2b. So minus 3, negative a minus 2b is equal to vector b. Now distributing this negative 3 inside the bracket, we would get x plus 3a plus 6b is equal to vector b. And then let's bring everything over and keep the x on the left side since we are isolating for it. So vector x is equal to 1b minus 6b. When we bring the positive 6 over, it becomes negative. That ends up being negative 5b, and then this positive 3a ends up being negative 3a. So we'd have negative 3a minus 5b. And that's it. So we found expressions for vector x and vector y in terms of vectors a and b. So as I mentioned, lots of algebra, but just follow these steps. Now, it might not always be this smooth. Sometimes when you isolate for x, you have to deal with fractions. However, the steps are always the same. You isolate for x or y in one of the expressions, then take that x or y, sub it into the other expression, and then isolate for the other vector, and then take that vector, sub it into one of the expressions, and isolate for the remaining one, and then you'll get your expressions.